This is our geometry review for Unit 10. We're going to determine whether the solid is a polyhedron. And we know that a polyhedron has to have all the sides made up of polygons. So for case number 1, yes, that would be a polyhedron. Number 2, no, that would not be a polyhedron because it has a circle for a side. Yes, number 3, we have a triangle for the bases and a rectangle for the sides. And even a pyramid is considered a polyhedron. All the sides are polygons. So the name of these, hexagonal prism. This would be not a polyhedron, but it is a cone. It has its own name, kind of like an ice cream cone. This would be a triangular prism. Okay, we have a triangle, but the sides are rectangles. So you have 2 triangles, those are the bases. That's different than a pyramid. A pyramid has triangles, but the triangles are actually the sides. The triangles go to a single point. The triangle prism does not. We have a pyramid. An architect is designing a contemporary office building in the shape of a pyramid. The office building will have 8 sides. What is the shape of the base of the building? It would be an octagon. This here, we have a 4-sided pyramid. This has 6 sides, but this is a prism. But if it came up to a point, it would be close to that. All right, cross sections. Cross section is when you slice down the 3D shape, and we're looking for the 2D shape that's being constructed. And we're not looking at the 3D shape. We're just looking at the stamp portion of it. Okay, name the cross section formed by the intersection. So this would be a pentagon. This here would be an oval. This here, yes, it's a cube, but the way they go in there at an angle, the sides are not the same as the other sides. So it is not a square. This is just a rectangle. If it was parallel to the bases, then yes, it would be a square. But in this case, it would be a rectangle. A net. A net is the unfolding of the 3D figure. So as this folds together, we would have squares on the sides and rectangles for between the bases. The squares would be your bases. That would be the best wording for it. The squares are the bases and the rectangles are the sides. So we would have a square prism. Here we would have a cylinder. A cylinder has circles for the top and the bottom, and then the rectangle would fold around, not fold so much, but it would roll around, and you would have a circular edge to encompass the circle for the bases. To calculate the volume. So to calculate the volume, we need to know the base and we need to times that by the height. Now the height is the distance between the bases. Our bases are triangles. We have a base in front, we have a base in back. So our base is half of 5 times 8. That is our area of the base. And we're going to times that by the 12. So we have 40 divided by 2, which is 20 times 12. And that comes out to 240. These are feet, and that would be cubed. Here we have a cylinder. We have 2 circles for bases. So again, you could call it base times height. That's your formula. But maybe it's better to call it pi r squared times height. because every cylinder has circles for bases. 9 is your radius, and 15 is the height. It's a perpendicular height. So we have to use that to help us determine what the height is. We cannot use a slanted height. Now, a cylinder doesn't have a slanted height, so it's okay, but it does occur. So we have 81 times 15, because 9 squared, that's our radius squared, times 15 is 1,215. Pi, that's what makes it an exact answer. They ask for the exact volume. So if we times this by pi, you would get a decibel, about 3 times bigger, or over 3 times bigger, but it would have all these decimal values. That would be an approximated answer. We want the real answer. So this would be feet cubed. So you need to have the pi with the answer. Here we have a rectangular prism. You could call the base the rectangle if you wanted to, and then you fill it up, or you could call the side a rectangle since it's 4 and 6 and it fills up sideways. But the volume is going to be the base times the height. Now you might say that the base is length and width, the length and the width. That's another way to describe the volume of a rectangular prism. But that's going to be 10 times 4 times 6. That's also 240 meters cubed. Here we have another cone. So the volume is 1/3 because it's a cone. It's different than a cylinder. A cylinder is pi r squared times the height. But notice that a cylinder goes up straight, but a cone comes down. So a lot less is filling this up. It's really only 1/3 of the total volume. So here we have 36 divided by 3, which is 12. And that would be 96 pi. And those are feet cubed. So that's 1/3 of what the volume is of a cylinder with the same size and shape. Here's a pyramid. Now notice that the value they're giving us is this slant height. Well, we need to come down right in the middle and come across. We need to know what the actual height is. We don't need the slant height. We need the height of the pyramid, the perpendicular to the base, straight up. So we have 5 here. Since this side is 6, notice that the triangle inside is not going all the way to the edge. So we would expect that to be 3. Most pyramids were under the impression that that is going to land right in the middle. When you drop it down, that splits this length in half. So a 3, 4, 5 triangle is your Pythagorean triple that can help you figure out what your height is. So then you can do your volume is 1/3 the base, which is 6 times 6, times your height, which is 4. So 36 divided by 3 is 12, and you get a volume of 48 centimeters cubed. Here again, we have a slant height. We're looking for the perpendicular height. We don't want the slant height. We need to know perpendicular to the base, perpendicular to the circle. So again, there's a little shortcut for this one. We know our radius of our circle is 5. 13 is a hypotenuse. You could say 13 squared equals 5 squared plus the height squared. That's the Pythagorean theorem. That's what I could have done here. 169 equals 25 minus the 25 across, and you figure out by taking the square root that your h is 12. You may have even realized that that's a Pythagorean triple. 5, 12, 13. It saves you a lot of work if you know your Pythagorean triples. Once you know your height, you can do 1/3 because it's the volume of a cone. The base is pi 5 squared times the height. The height is 12. So we get 1/3. 12 times 25, which is 300 pi. This comes out to 100 pi, and these are meters cubed. Remember, we're looking for the exact answer, so we want pi to be in the answer if possible. For any of the prisms or the pyramids, we don't have to worry about pi. So your answer is exact. So solve for x, given the volume. If we're given the volume, all right, this is you can call it length times width times height. You can call it BH, capital B for the base and H for the height. But what we're pointing out is that we don't know what this portion, that's the x. So we don't know what the x is, but we do have the 6 and we do have the 8. So that is 48. We take our 576 and divide that by 48, and we come up with 12. So x is going to be 12. These are going to be meters. It's not meters cubed. You don't have meter times meter times meter in this calculation. You actually are dividing those out, and you're left with just one dimension, which is one dimension is all m. It's just meters. Here we have our triangle. So we're going to have to find the area of the triangle, but then calculate what the distance is in between. We know the volume is going to be half the triangle area, which is base times height, times the distance between the two bases, which is often called height, and that gets a little confusing, but that's going to be our x. So our volume is 132. Our base is 6, our height is 4, and our x, we have 12. Here we get 11 equals x, and that's 11 feet. For us to have a volume of 132, we'd have to have the triangle base, and the distance between the bases is 11. Volume equals pi r squared times the height. That's the area of a cylinder. We have 1,000 equals pi. Our radius is 8. We're squaring that times our unknown value. Notice we have one unknown. We cannot solve for two unknowns in these situations. So we have to know the volume, and we have our one unknown of not knowing the height. So we have 64x times pi. That has to equal 1,000. We're going to divide the 1,000 by 64. That's 15,625. Then we can divide by the pi. Here they want to round to the nearest 2 decimal spots, so we don't need to worry about keeping pi in the answer. 497. And these are centimeters. Here's our pyramid. The volume of a pyramid, remember, is 1/3 the base times the height. And in this case, the base is a rectangle, so it's 8 times 4, and the height is our unknown. So we have 48 times x, take 1/3 of that, 3 goes into 4 one time with 1 left over, so 16. We divide by 16, and x equals 4. The height would have to be 4 inches. Number 21 is requested. This is your cone. So again, your volume is 1/3 pi r squared, because that's your base. It's the same formula as over here, but it's the base is a circle. Here, the base is a rectangle. The circle times the height. So we have 147 equals 1/3 pi times x squared. We don't know what the radius is. So we can take 1/3 of 9 if you want to get rid of the 1/3. Now we have 1/3 of 9 is 3, x squared times pi. We're going to divide by 3. So 147 divided by 3, we get 49. All right. Unfortunately, we still got to work with this pi thing. So we're going to divide by pi. It almost looks like we could take the square root of that, but no, you can't. You got your 49 divided by pi. You got 15.60. That is what x squared equals. And then we take the square root of that. Take the square root of our answer. We get 3.95. That would be our radius, and that would be in centimeters. Find the volume of the solid. Here we have a 30, 60, 90 triangle. Now, a few people were talking about solving this using trigonometry, maybe cosine adjacent over hypotenuse. You could do that. You would come up with 11. Notice that this is a 30, 60, 90 triangle. The short leg is always half of the hypotenuse. It's going to be 11. And the long leg is going to be 11 root 3. Some of you may have solved it using trigonometry, opposite over hypotenuse, using sine of 60, and you got 19.05. But 11 root 3 is more accurate. So now my volume is pi r, which is 11 squared, times the height, 11 root 3. So we have 121 pi times 11 root 3. 11 root 3 times our 11 squared, which is 121. That comes up to be 2,000. 2,305.36. Rounded to 2 decimal spots. And that would be, that would be without using the pi yet. So then we have to times that by pi, I believe. So actually we get 7,242.5. That came out not so bad. Units cubed. Remember, volume is cubed units. A sphere, the volume is not 3, but 4. 4/3 pi r cubed. If the radius is 7, we know that 7 cubed, 7 raised to the 3rd power is 343. All right, you can divide that by 3 and times that by 4. Then we have this value times pi. So we times it by pi and we get a volume of 1,436.76 feet cubed. Okay. Here we have our perpendicular height. Now it seems a little weird having the height off to the side like that, but we've learned, oh, it's got to be 1/3. 1/3 pi times 6 squared times 11. That's not a slant height. That is a perpendicular height. So we're going to have 12 times 11, 132 times pi. That's probably your best answer. I prefer that more than 132 times pi. Prefer the exact answer more than a decimal, but they are asking for a decimal. So this was meters cubed. All right, we're a little bit short on time, but just to do a little highlight for a few of these, we have a prism, plus we have the pyramid. Okay, so you would have to add those two together. Here we have a pyramid, plus we have another pyramid. Here we have a cone, plus we have a cylinder. So you'd have to find the volume of each one of those. And working down here at the bottom, we'd be setting those up in a similar format to how we calculated the rest of our problem. With number 30, we have a right cone. Right just means that it's standing up straight with a height of 6 and a volume of 32 pi. The pi is the important part there. So you know that volume is 1/3 pi r squared times the height. So if we have 32 pi with a radius of our unknown times 6 as our height, we can take 1/3 of our 6. That leaves us with 2. We can divide by 2 pi. The pi's cross out. The 2 reduces to get 16. And take the square root, which gives you 4. So it's going to be 4 feet. What is the approximate radius of a sphere? Okay, the volume of a sphere is 4/3 pi r cubed. We've got 128 pi. Again, notice the pi symbol. It makes the calculation so much easier. 4/3 pi r cubed. We're trying to calculate what your radius is. Calculate the radius. So we're going to divide by the pi, make the pi go away. All right, now we have 128 times 4/3 r cubed. You would times by 3 first. 128 times the denominator gives us 384 4r cubed, and then divide by 4. Gives us 96 equals r cubed. So if we do the cubed root of 96, we'll get our decimal of 4.58. And these are centimeters, 4.58. Notice it wasn't a guessing game. It wasn't a plug in and guess game. It was calculate it and pick your solution.